Good evening all. Welcome to ACE Engineering Academy. Myself K. Hanumantha Rao, faculty in Electrical Engineering. Today I am here to interact with you for the discussion of a revision session for lecturers in Government Polytechnic in Technical Education Service, General Recruitment. Under the Electrical Engineering, the revision classes today going to be started. Now, this class, the entire class 1 hour, I am going to take that for electrical circuits. What are the questions you are going to get it? Guys, yesterday you have seen that whatever the discussion we made under EEE examination for SPDCL, I have given each and every basics, but today I would like to consider that I don't want to give that theory part. Each and every topic we are going to discuss the examples, previous examination questions and expected questions. Previous examination questions and expected questions discuss చేద్దాం. Theory part పక్కన పెట్టేద్దాం. Okay? Are you ready? Are you ready? Are you ready all of you? రైట్ ఈరోజు ఈచ్ అండ్ ఎవ్రీ టాపిక్లో ఎగ్జాంపుల్స్ తీసేసుకొని డిస్కస్ చేసుకుందాం. ఐ డోంట్ వాంట్ టు ప్రొవైడ్, ఐ డోంట్ వాంట్ టు గివ్ దట్ ఎనీ థియరీ పార్ట్. ఇట్ ఈస్ ఎ టైమ్ కిల్లింగ్ ప్రాసెస్, రైట్? అండ్ ఇన్ ద క్వశ్చన్ ఇఫ్ థియరీ ఈజ్ రిక్వైర్డ్, ఏమైనా థియరీ రిక్వైర్మెంట్ ఉంటే మనం డిస్కస్ చేద్దాం. ఓకే, నౌ హియర్ బిఫోర్ గోయింగ్ టు దట్ I would like to present that first, what is the scheme of the examination for this one and what is the syllabus under electrical circuits. ఈ electrical circuits లో syllabus ఏముంది, ఆ syllabus ప్రకారం what is the weightage of that one. నా సబ్జెక్ట్ వరకే, this subject what is the weightage of that one, that I will discuss. Then I will take that each and every topic questions, right? Are you ready? Okay. This is the scheme of the examination. You know that this is 150, totally 450 marks, 150 questions, 300 marks for technical version. Now, this is the syllabus under electrical and electronics engineering, electrical circuits and fields. Are you getting? This is the electrical circuits and fields. The electrical circuits and fields lo, the fields part, you can take it, the fields part, this part you can get that up to this. The rest of the all, I can divide this total syllabus under electrical circuit into 7 topics here, major 7 topics. And ఈ electrical circuits subject నుంచి minimum 15 questions వస్తాయండి, 15 to 16 questions వస్తాయి, right? According to that previous examinations, I can say that 15 questions you may get it that. Now, as per this, I can say that here, the next one, I can divide these 7 topics. This is the 7 topics, right? This is circuits. First, 3 marks, you may get it that, or 3 questions, not marks here, number of questions. Each and every question is 2 marks. That's why this you will take that questions, 2 questions, 1 question and 1 question, right? And AC circuits, network theorems, transient circuit analysis, 2-port network parameters, graph theory, compulsory question and graph theory lo. Graph theory lo you will get the compulsory question, okay? Now, let us start one by one the questions. I am not giving any theory for this one. Let us start the questions, right? Now, let me consider that one by one. Are you ready? Everyone? Are you ready? Very good here. Now, the first topic, the practice questions. Here I am going to give that all the practice questions, topic wise, all the practice questions which are expected and previous examination questions, topic wise I will consider, right? Manam topic wise discuss cheddam, right? Now, the first one is basics, basic concepts we are considering that. Yesterday we have taken that every examination lo basics lo bulbs problems compulsory అండి, bulbs problems compulsory. ఈ bulbs problems లో today I would like to take that at least 5 to 7 minutes on the bulbs problems, because some of the students they are asking that, sir, we have some doubts regarding the bulbs problems, you please clarify that bulbs problems, right? Whatever the lamps given, that question in any direction if it is given, you are able to answer. ఏ డైరెక్షన్లో మీకు క్వశ్చన్ ఇచ్చినా కూడా ఇప్పుడు మనం డిస్కస్ చేసే దాన్ని బట్టి ఏ క్వశ్చన్ అయినా రిగార్డింగ్ ద ల్యాంప్స్ ఆర్ బల్బ్స్ యూ కెన్ ఆన్సర్. నౌ ఈ క్వశ్చన్ చూడండి. two light bulbs are connected in series across 120 volts battery and one uses 40 watts. Uses ante, remember that uses means this is consumption, it is not rating. And bulb 2 20 watts. Uses means consumption. There is a difference between that bulb rating and bulb consumption, right? Bulb rating and bulb's consumption. And if it is rating is given and bulb consumption is given, there is a difference, right? Consumption is always depending upon that connection, whether it is series connection or parallel connection. Series lo connect chesara, parallel lo connect chesara, danni batti decide avutadandi, right? Uses ante endante here the rating is always fixed. 40 watts bulb తీసుకున్నాం అనుకోండి, that maximum 40 watts వస్తుంది. అది 40 watts కన్జ్యూమ్ చేయొచ్చు, తక్కువ చేయొచ్చు, రైట్? బట్ maximum 40 watts. సిరీస్లో కనెక్ట్ చేసామనుకో తక్కువ కన్జ్యూమ్ చేస్తుంది, ప్యారలల్లో కనెక్ట్ చేసామనుకో maximum 40 watts ఇచ్చేస్తుంది. Based on that, now here according to this, here I would like to give some introduction for this problem, the difference between the light or bulbs rating and consumption. Bulbs rating and consumption. Here you have to take that bulb rating is fixed and consumption consumes is variable based on connection. Right, based on connection. ఈ క్వశ్చన్కి ఎట్లంటే యాక్చువల్లీ 2 bulbs are connected in series. Now, according to that, I can say when 2 bulbs are connected in series, 2 resistors అనుకుందామండి, across 120 volts. This consumes, first one consumes how much? This consumes 40 watts, this consumes 60 watts. ఇది 40 watts consume చేస్తుంది, 60 watts consume చేస్తుంది. Remember that consumption is very important. Total power PT is equal to 40 plus 20 which is equal to 60. ఈ 60ని మనం ఎట్లా చేయొచ్చు అంటే, కరెంట్ ఇఫ్ యూ వాంట్ టు ఫైండ్ అవుట్ దట్ V into I is equal to 60 by 120 which is equal to 1/2 amperes. ఇదండి. Now, what is the question? He was given that if you see that question, ఈ బల్బ్ 1 alone across 120 volts లో కనెక్ట్ చేస్తే ఎంత పవర్ కన్జ్యూమ్ చేస్తుంది? ఫర్ దట్ వీ నీడ్ టు ఎస్టిమేట్ ద రెసిస్టెన్స్ ఆఫ్ ది బల్బ్. ఈ కన్జంప్షన్లో రెసిస్టెన్స్ ఆఫ్ ది బల్బ్ కావాలి అంటే కన్జంప్షన్ ఈజ్ డిపెండింగ్ అపాన్ ద కనెక్షన్. సిరీస్ కనెక్షన్లో పవర్ కన్జంప్షన్ ఈజ్ ఈక్వల్ టు I²R ఇన్ సిరీస్. రిమెంబర్ దట్, in series. ఎంత ఇచ్చాడు ఇక్కడ? he was given that 40 and I value is equal to 1/2 whole square into R1. R1 is equal to how much? 160 ohms. Are you getting this? నీకు 160 ohms వచ్చేసిన తర్వాత here he wants to connect that only this first bulb A. This is R1 and R2. Now RA, R1 which is connected across where? Across 120. Then you can take it, this power consumed by this one is, you can take it by current or by knowing the voltage you can take it V square by R1, 120 whole square by 160 which is 90 watts. You are getting that? Yes or no? This is the procedure you have to follow for that example. ఎందుకంటే మనకి కన్జంప్షన్ given, that's why we have used this formula. సపోజ్ రేటింగ్ ఇచ్చాడు అనుకోండి, రెసిస్టెన్స్ వాల్యూ కనుక్కోవాలి అంటే కంపల్సరీగా యూ షుడ్ గో ఫర్ దాట్ V²/R ఫార్ములా. రేటింగ్ ఇస్తే ఇక్కడ కన్జంప్షన్ యూజెస్ అన్నాడు, అందుకని కన్జంప్షన్. నార్మల్లీ రేటింగ్ ఈజ్ గివెన్, హౌ యూ ఫేస్ దీస్ ప్రాబ్లమ్స్. లెట్ మీ సీ దట్. ఐ ఆమ్ గివింగ్ దట్ క్విక్లీ, ఐ విల్ రివైజ్ దిస్. whenever if the rating of the bulb is given, if you go on see or if you want to buy a bulb which is having 60 watts, if you go to store and buy the 40 watts or 60 watts bulb. On the top of the bulb, you may identify that, definitely will identify that 60 watts and 120 volts voltage rating ఉంటుంది. That means what? The filament which is designed based on that voltage rating. అంటే ఈ resistance of the filament, if you want to find out V square by P formula, we cannot use this formula. We cannot use this formula. ఈ ఫార్ములాని యూజ్ చేయకూడదు, right? And once you use this, estimate the value of the bulb resistance. Remember this, ఎందుకంటే bulbs or loads are always connected in parallel. They are designed based on the voltage rating. Now here this is resistance 1, resistance 2. If both are connected in series, these are the ratings. Remember that here P1, P2 are ratings. Are you getting that? P1, P2 are P1, P2 are ratings. ఈ రేటింగ్స్ ప్రకారం you have to estimate that R1 and R2 values here. Are you getting? R1 and R2 values. Once you obtain that R1 and R2 values, total resistance value, total power dissipated by this one is equal to R1 plus R2, because both are connected in series. Now while coming to this here, if both are connected in series, resistance of the bulb is inversely proportional to power, right? That's why the resistance value is inversely proportional to power. 1 by Pt is equal to 1 by P1 plus 1 by P2. Pt is equal to P1 P2 by P1 plus P2 when P1 P2 are the rating of the batteries. This is very important. Rating of the bulbs. Rating of the bulbs. If both are equal, Ps by 2. If both are not equal, you can use this formula. While coming to that parallel one. While coming to that parallel one. E parallel lo, if two bulbs are connected in parallel, procedure is same and estimation of resistance formula is in series case. See this one. In series case, in parallel case, this is the formula we are using to estimate the value of resistance of filament. Once you take that in parallel, total power kavalante, in parallel resistance 1 by R equivalent is equal to 1 by R1 plus 1 by R2. While finding that resistance value, ikkada manamu resistance value find చేసేటప్పుడు series లో parallel లో same formula ni count చేసాం. That is V square by R. That's why power is inversely proportional to resistance. Here also inversely proportional to resistance. Now Pt is equal to P1 plus P2. Nothing but in parallel we can get, or we can add it, the total rating of the bulbs. That gives the total power P1 plus P2. Right? This is the difference between the rating and consumption. Previous question was given consumption. Now in this case, suppose if it is given n bulbs are connected in series with the same power rating Ps, total power consumed by the network is equal to Ps by n. In series lo connect cheste, parallel lo connect cheste n into Ps you are getting that. This you have to identify. Here this Ps is what? Rating. Ps is what? Rating. Or PP, nothing but parallel. Suppose if you take that one question, a simple question, see this one. The number of bulbs are rating here 200 watts volts in series, which would consume the same power as 50 watts parallel connection. Lamps are connected in parallel. Ante here 200 watts 220 volts oka lamp తీసుకున్నారు and 50 watts 220 volts ఇంకొక lamps తీసుకున్నారు. Any lamps connect cheste, either series or in parallel combination, this combination will have whatever the power consumed, same power consumed by the parallel combination. Are you getting that? Here Ps is the rating of the power and Pp is the rating of the power for parallel connection, for series connection. Any bulbs ni manam series lo connect cheste ee rating toti, ee 50 watts rating toti any bulbs ni parallel lo connect cheste, we will get that same power dissipation. For that, series power is equal to parallel power. Now PTS series connection, PT parallel, Ps by n and n into Ps. Now with this 200 by n is equal to n into 50, n square is equal to 4, n is equal to 2. Two bulbs ni series lo connect cheste with 200 watts toti ento ostadi 100. Two bulbs ni 50 watts toti parallel lo connect cheste 100 ostadi. Simple. That's why n square value is equal to here. This is the formula we can take it. Ps by n is equal to, or Ps is equal to n square into Pp, where Ps, Pp are rating of the bulbs, not consumptions of the bulbs. Right, see this. Two bulbs are 40 watts. This is the rating here. 40 watts, 60 watts, which are connected in series. Then which bulb will glow brighter? Obviously, if you see that the resistance of this bulb is greater than resistance of this bulb. In series, current is same, I square into R1, I square into R2. Which resistance is more? Less power rating resistance is more. That's why this 40 watts will glow brighter. Is it right? 40 watts will glow brighter. And according to this here, total power we are getting 24 watts. Total R1, R40 is equal to R1 I have taken, and R60 is equal to R2 I have taken. Now, in series, current is same. The power consumed by this one, I1 square into R40 and I square into R60. Which is more? Power in R40, power in R60. Which is more? Resistance value of this is more. Resistance value of this is more. Power ఎందుకు డైరెక్ట్లీ ప్రపోర్షనల్ తీసుకున్నాము? బికాస్ దిస్ ఈజ్ ద వాట్ కనెక్షన్? సిరీస్ కనెక్షన్. విచ్ రెసిస్టెన్స్ ఈజ్ మోర్? 40 వాట్స్ రెసిస్టెన్స్ ఈజ్ మోర్. అండ్ ఆల్సో పవర్స్లో కూడా మనం తీసుకోవచ్చండి. 1/40 ఈజ్ ఆల్వేస్ గ్రేటర్ దాన్ 1/60. దట్స్ వై 40 వాట్స్ బల్బ్ విల్ గ్లో బ్రైటర్. రైట్ నౌ ప్యారలల్లో కనెక్ట్ చేస్తే ఏ బల్బ్ ఉంటుంది? 60 వాట్స్. ప్యారలల్లో ఏ బల్బు ఎక్కువ మోర్ రేటింగ్ ఉంటుందో దట్ బల్బ్ విల్ గ్లో బ్రైటర్. ఆల్ ద లోడ్స్ ఆర్ కనెక్టెడ్ ఇన్ ప్యారలల్ ఓన్లీ. రైట్, all the loads are connected in parallel only, because parallel connection will give the two advantages. First one is we will get the maximum output from the corresponding load, and also we can get that if any one of the load get damaged, my system will not disturbed. These are the two advantages. Okay, have you got the clarity regarding the bulbs problem? Let me consider that next one. You see that. Tell me the answer for this. Have you got the clarity? Please respond here, any one of you. Have you got the clarity? Consumption rating. Consumption rating, right? Now tell me this one. Two lamps of weightage 40 watts, 60 watts are connected in series with a voltage of 230 volts. Which out the two lamps glow brighter? Which one? Which will glow brighter? 40 watts, same formula, right? Same question. Same question. Next question, chudandi. Have you got the clarity, guys? Please respond. Okay, very good, very good. Good evening. Right. Tell me the answer for this one here. Basic concepts. Tell me the answer. The question is, find the values of R1 and R2 in the following circuit. Tell me the answer for this one. Good evening, Ashwini. Good evening, Teja. Good evening, Ravi. Tell me the answer for this. Now, how you proceed for these type of examples? See this one. All are in parallel. In parallel, voltage is same. That is the main rule here. Voltage is same means here how much voltage you are getting? That 30 volts only. Because these N terminals are same. Now 30 current, you know that. R2 value is equal to 15 ohms now. Now this total here, how much current is entering? 5 amperes, 2 amperes, rest of here 3 amperes. Now total voltage, how much here we are getting? The total voltage is equal to 30. Out of 30, 9 volts is here. This is the 9 volts because 3 amperes is there. Na? Out of 50, 9 volts is 30, 9 volts is here. Rest of the voltage 21 volts here we are getting. Na? 21 volts means 21 by R1 value is equal to 21 by 3. How much that? 7 ohms. Now R1 is 7, R2 is 15. Option A is the correct one. Have you got this? Very good, very good. All are giving correct answer. Shall we move the next example? Take this one. Right. If the voltage applied across a capacitor is a triangular in the waveform of current. Guys, here under basic concepts, you should know the relation between the voltage and current here. Now for capacitor opposes rate of change of voltage. Nothing but here current I is formula across capacitor C into dV of t by dt. Differentiation of triangular. Differentiation of triangular will be is equal to d of triangular. I can say that d of triangular. D of triangular by dt. What we are getting that current expression, differentiation of triangular, what we are getting that rectangle, you will get it that this is rectangular. For this one, I have given already one variation. Suppose if you are considering that here, this is a triangular waveform. This is a triangular waveform. This is triangular waveform. If it is given triangular waveform, then differentiation of this d of by dt will be is equal to, here you are getting this is the voltage, suppose 10 volts given, here 10 volts given, definitely you will get that from here to what we are getting that, from here positive slope we are getting that. From this we are getting here up to this here we are getting the positive slope. Then this is the current I, and from this I can take it from here to here negative slope here. From here to here negative slope. This value you are getting. This is the way how we can take it. The current function. Current function is a rectangular waveform. From here to here it is the again positive, again negative. This is minus I. This value or the nature of that. We don't need estimation of, current magnitude. Directly you can take it here. You need not go for any calculations. Right? Rectangular which is that? B is the correct one. Right, very good here. Now see this next one. Good example. The question is, two impedances R plus jx and R minus jx connected in parallel offer a resistance 1 ohm. When they are connected in series, offers resistance 2 ohms. Find the impedances. Now for this one, definitely we should go for that here. Both are connected in series, for series connection and for parallel connection. See this series connection, what we are having that? For series connection, if you add these two, now Z1 plus Z2, suppose if you consider this is Z1 and this is Z2, Z1 plus Z2 is equal to, what we are getting, 2R na? How much it is given? 2 na? From this R value is equal to how much? Here 1 ohm we are getting na? Yes or no? R value is equal to 1 ohm we are getting. Once you are getting that R value is equal to 1 ohm in parallel connection. In parallel connection, here Z1 Z2 by Z1 plus Z2, which is given as how much given? The value is in parallel connection, it is given as 1 ohm given. Now you know that R value 1 ohm. Now you can take the X value. Tell me that here Z1 value is equal to 1 plus R value is equal to 1 plus Jx into 1 minus Jx by 2 we are getting, because imaginary part will be cancelled. Now what we are getting that A plus JB, A minus JB, A square plus J square. This is very simple here. 1 square plus X square is equal to 2 we are getting. Now X value how much you are getting, that X square is equal to 1. Now X is equal to 1 we are getting that, or plus or minus 1. Based on that value you can take it that. Based on that value you will consider that. Now here 2R we are getting. Now from this 1 minus J2 or 1 minus J, 1 plus J, option B is the correct one. Z1 is equal to 1 plus J and Z2 is equal to 1 minus J. Is it right? Is it clear? He was given that option. Which is the correct option? Very good, very good. B is the correct one. Now tell me the next one. Determine the total resistance between the terminals A and B for the following. Tell me here, this is your job. I don't want to do this. You need to do this. Just I will provide that how you have to follow. These three are in series. 60, 60, 30, 20. You know that standard combination. Standard combination, you see that? You remember the standard combinations here. Standard combinations. Standard parallel combinations. Parallel combinations. What we are getting that parallel combination? 6 parallel with 3, it is 2. Remember that. 4 parallel with 12, which is 3. 6 parallel with 12, which is 4. 5 parallel with 20, which is 4. Remember this part. Once you remember, this is very much useful for the direct formulas, you can take it. Yes or no? Now from this I can take it, this value, how much you are getting that? This value is equal to 20, we are getting that? This value is equal to 20. Now 20 plus 20, 40. 40 and 40, how much you are getting that? 20. 20 plus 10, 30 you are getting. Very good. Option C is the correct one. Right? Next one. Right. What are the unknown currents I5 and I3 respectively for the circuit shown in the figure? Just concentrate where we are getting that I5 and I3. These values you have to consider here. I5 and I3. This is I5 and where I3? I3 is given here. Now tell me this. See the circuit here. See the circuit. Are you doing? Are you doing? Tell me this. How much current? 10 amperes is entering and 5 amperes is leaving. 5 amperes. I4 is equal to 3. Then I5 is equal to what? 2 amperes now. Very good. I5 is equal to 2 amperes. And here 5 amperes, out of that 5 amperes 4 and I3 is equal to what? 1 ampere. And see this, first I5 is given, next I3 is given. You may think that I3 and I5, but according to that here whatever the sequence is given I5 and I3, I5 is 2, I3 is 1, 2 and 1, 1 and 2 also there be. Examiner always try to confuse you, then on the time we should be careful what order we are mentioning that. What order he was given that I5 and I3. I5 and I3 values ni 2 and 1. It is not 1 and 2 here, not I3 and I5. Shall we move that next example? Very good. Is it clear? Right. This is about that basic some of the concepts questions. Now let me consider that next AC circuit analysis, second one. In this one, 3 questions compulsory you will get it here. The weightage for the AC circuit analysis is 3 questions. Now average value, instantaneous values to extend that this is the formula. Whenever if it is given RM average value any function, this is the formula according to the Simpson's and trapezoidal rule. Okkasari mathematics ni intermediate mathematics lo, then definitely you will get a function within the time interval, complete cycle A comma B, this formula we have to take it that. Okay? Now, or area under that curve also we can take it, I average. That one also sometimes you can use it. Now, this sinusoidal waveform ki here oka cycle ante repetition occur in equal interval. Time period ante time taken one complete cycle ante. Repetition occur in equal interval is nothing but one complete cycle. And if area under this positive half cycle, negative half cycle is same, average value is equal to 0. Whenever any alternating quantity average value is equal to 0, then that type of waveform is called symmetrical waveform. For sinusoidal waveform, average value is equal to 0. And if it is unsymmetrical waveform is there, then definitely area for the positive half cycle is not equal to area under negative half cycle. Symmetrical waveform kemo area under positive half cycle should always equal to area under negative half cycle. Then average value is equal to 0, symmetrical waveforms, right? Let me consider that RMS value. RMS value means root mean square value. In reverse order we can take it, squares mean of root value here. Squares mean of root value. ఇక్కడ individual తీసుకున్నప్పుడు average value. ఇప్పుడు squares mean means what? Mean is nothing but it is again, mean value means what? Again average value. Now, if you want to take that average value here, means squares mean of root value. Squares mean తీసుకుంటే square value వస్తుంది. మనకు actual value రావాలంటే root తీసుకోవాలి. That's why this is the instantaneous values తెలిసినప్పుడు This one is whenever if you know the function within the time interval, this you have to take it. Right. Either symmetrical or unsymmetrical RMS value never be equal to 0. That's why circuit values ni RMS values ka తీసుకుంటాము. మన analysis లో circuit values ni RMS values ka తీసుకుంటాము. And whenever if you are considering that circuit values are always RMS values under AC circuit analysis. RMS value is nothing but effective value. Sometimes effective value adugutundi, which is also called circuit value. Form factor you can define RMS value by average value. Peak factor define peak value by RMS value, or sometimes peak factor is also called crest factor. Peak ante crest andi. Last time you given this one crest factor same as maximum value by RMS value, right? Is it okay? Now let me take the here some of the standard signals ki meeku direct ga telusu undalandi. You should know that what are the average value, RMS value, form factor and peak factor. Eetiki suppose if you are considering that I have taken nearly 8 standard signals I am going to be considered here. DC excitation V1 form factor, first average value, second one is RMS value, third one is form factor, peak factor andi. Ikkada sinusoidal waveform ki average value is equal to full cycle ki 0, because this is what? This is the symmetrical waveform. Half cycle ki 2Vm by pi. VRMS is Vm by root 2. And form factor equal to 1.11, peak factor is equal to root 2, 1.414. Half wave rectifier kochesalki, you see that while taking that half wave rectifier, under half wave rectifier I can say that for half wave rectifier, see this one, Vm by pi, Vm by 2, and form factor pi by 2, peak factor is equal to 2. Now the full wave rectifier ki same ide vastandi. You can also remember that. Full wave rectifier ki sinusoidal half cycle ki both are same. Now let me take this for full wave rectifier. Suppose if you are considering that for full wave rectifier 2Vm by pi, this unsymmetrical waveform. This is the unsymmetrical waveform. Vm by root 2, 1.1, same sinusoidal waveform ketla vastundo, half cycle of sine wave. And symmetrical square waveform, you are getting Vm 1 1, and unsymmetrical waveform, unsymmetrical square waveform ki Vm by 2, Vm by root 2, root 2, root 2. And you should remember one more thing, sometimes this gap is not equal to this gap here. Under that instant, these two gaps are not equal, you can use this formula x by, if you take the positive half cycle, this is the half cycle is x, full cycle is y, then x by y into Vm. Maximum RMS value how much? Under root x by y times of Vm. Remember this one. Is it right? Have you got the clarity? This one? Is it okay? This clarity? If it is both values are half cycle, full cycle, it is not the half of that one. Full cycle is not half of the next half cycle. That means what? This positive half cycle and negative half cycle both are not equal, then definitely we should use this formula. Okay? And this is the symmetrical triangular waveform here. Under triangular waveform, we can take it. Triangular waveform Vm by 2, Vm by root 3, 2 by root 3 is the form factor root 3. And triangular waveform, unsymmetrical triangular waveform also here, symmetrical ante full cycle తీసుకుంటే 0. Half cycle తీసుకుంటే Vm by 2. Like that here, values are same. These values are same. Right? And sawtooth waveform here. What is the main difference between that unsymmetrical triangular waveform and sawtooth waveform? Ikkada positive half cycle here we are getting only positive slope and negative slope. Both are existing in unsymmetrical. But while coming to the sawtooth waveform, only positive half cycle. Positive slope, sorry. Only positive slope. The response changes abruptly. Even though if you are identifying like that, but there is no difference between that what? There is no difference between these values. These values here, both are same. Both are same. There is no difference. Now ivi gurtubettukovalandi. You should remember these values. This is very important. Okay, got it? Is it clear? This part, is it clear? Shall we move the examples? Right, let me consider that examples. Last examination, this question is given. Tell me this. Find the root mean square value of sawtooth waveform. Now, this is your job. Tell me that answer. Tell me the answer. Find the root mean square value of sawtooth. Sawtooth waveform ki root mean square value how much? Just now we have seen Vm by root 3. Tell me here, it's very simple. Na? Vm by root 3. What is that Vm by root 3? Vrms is equal to Vm by root 3, which is equal to Vm value how much? 50 by 50. Okay. This is 50 here. Okay, you are waiting for that one. 50 by root 3 is a 28.9 you are getting now? Very good. Excellent. Next question, we will see that. See this one. An RL series circuit has Z is equal to 6 plus J8 ohms. Its susceptance is equal to what? Good example here. Susceptance and here conductance is nothing but related with the admittance words. Admittance words. Series circuits aithe, now let me consider that in series we will consider in series impedance can be added R plus or minus Jx. In parallel admittance can be added G plus or minus Jb, where we are considering that R, here R refers what? Resistance. X refers reactance. You know this. Here G refers conductance and B refers susceptance. Are you getting this? Susceptance. Now, ఈ Z value ఇచ్చాడండి. Z value series circuit కి susceptance కనుక్కోమంటున్నాడు. Susceptance అంటే ఏంటి? First you should take that admittance. Susceptance, conductance can be defined for admittance. This is impedance and this is admittance. Tell me that, you can get it. Now 1 by Z na, 1 by Z and here 6 plus J8. Then you should write in this form. You should write in that form. Now you should rationalize that. Once you rationalize that 6 square minus J square 8 square, how much you are getting? 36 plus 6400. Now we are getting 0.06 minus J into 0.08. This reflects, what we can take it? This reflects here, I can say that this is conductance, this is susceptance, 0.08 mhos, which is the correct option, 0.08 mhos, nothing but option 2 is the correct one. Very good here. 0.08 mhos. Let me take the next one. Shall we move that? Okay. A phasor is rotating with an angular velocity of 628 radians per second. Determine the frequency of the phasor and time period. This is very simple here. Tell me this. Tell me, you can give the answer for this one. Now, omega value is equal to, how much given? 628 radians per second. Omega means what? 2 pi f is 628. F is equal to what? 628 by 2 pi. Pi means what? 3.14. No? Nothing but 6.28 we are getting. No? How many times? 100 times. 100 edges. Now time period means what? You know that. What is the time period? Time period is equal to inverse of frequency. Inverse of frequency means what? 1 by 100, which we can take it. This one is 10 power minus 3, if we take it 10 milliseconds. Yes or no? Which is the correct option? Option A, 100 heads and 10 milliseconds. Very good. Very good. All are given a correct answer. Simple questions, but you may have some confusion. That confusion, you should remove that. Definitely, once if you are not having any confusion, then definitely you will get it. That small confusion, you should have clarity. Right, this one. The current waveform is shown in the figure below. What is the average value of that one? What is the average value? What is the average value over the time interval? 1 to 7 seconds here. 1 to 7 seconds ante this one we need to concentrate. 1 to 7 seconds. Right. This one we need to concentrate. 1 to 7 seconds. This one you have to concentrate. By taking this one, this is the 1 to 7 means what? 6 seconds na? ఈ 6 సెకండ్స్లో ఏ వాల్యూ కనుక్కోమన్నాడు? యావరేజ్ వాల్యూ. యావరేజ్ వాల్యూ అంటే దిస్ ఈజ్ ద వాట్ వేవ్ ఫామ్? ఇర్రెగ్యులర్ వేవ్ ఫామ్. దట్స్ వై వీ షుడ్ గో ఫర్ దట్ ఏరియా వర్షన్. Average value, area. This is what? This area I can take it that average value of this value. This is the what function, right? Current function. I average is equal to, I can take it. What is this? Here 3 minus 1, 2 into 1.5. Very good. And this one is what? This average. 5 minus 3, 2 into minus 2. 2 into minus 2 means what we are getting? 2 into minus 2 minus negative. No? That's why we need to consider that. From 5 to 6 it is 0 plus 0, and 6 to 7. 6 to 7 we have to consider that plus 1 into 1. 1 into 1. Now finally what we are getting that by total time interval is 6 seconds. Now numerator I average value, right? By knowing the instantaneous values, we should consider that average area under that one we can take it directly. Here if you want to get instantaneous values you can take it, or otherwise you can go for that area. Area we are getting here directly. This area we have taken the I average means area of this one. Here 3 minus 4 plus 1 which is equal to 0 here. Option C is the correct one. Is it right? Are you getting? Is it okay? Very good. Area, not by. Instantaneous values తీసుకున్నప్పుడు ఏంటంటే that instantaneous value into the time interval by the total we have to take it. That is different. Right? This we have taken area under that curve. This is the area under that curve. Area. Next question. Shall we move that next question? Okay, very good. The voltage phasor of the circuit is 10 at an angle 15 degrees volts, and the current phasor is equal to 2 at an angle minus 45. The active and reactive powers. Now, in this one, the solution you can take it whenever active and reactive powers kavalante, apparent power తీసుకోవాలండి. V is equal to, S is equal to VI complex. V is 10 at an angle 50 degrees and 2 at an angle minus 45 degrees. With this 20 at an angle. Complex na? Complex means plus 45 you will get it that. Once you are considering that plus 45, now 40, sorry, this is, right, 10, 20 at an angle 60 degrees, which we are getting 20 cos 60 is 10 plus j times of, what we are getting, considering that 10 watts and root 3 by 2, nothing but 10 root 3, nothing but 10 plus 17.32 j. This is active power and this is reactive power. This is the active power and this is the reactive power. Which is the correct option? Very good. Option A is the correct one. Got it? Are you getting this? The solution how you have taken? ESC questions are enough here. If you are considering that, because each and every question is 2 marks question, should go for like this. Now see that a series RLC circuit is connected across single phase AC source. The voltage is measured across RLC 20, 40, 55 respectively, and the ammeter measure supplies the current of 3 amperes. What is the power factor of that? Definitely if all are connected in, this is what across single phase a series RLC circuit. Now once you take that series RLC circuit, first you can take it, here you need not go for this one, directly we are having the power factor. Power factor formula, what is the power factor formula you are having that? Yesterday we have taken the solution under this one, power factor for RLC series circuit cos phi is equal to, for series circuit, VR by V or VR by Vs here, series circuit. Current also no need the current here. Now Vs value how much? Vs you have to find out that under root VR square plus VL minus VC. Observations and once you see the observations, definitely you will get those observations. 20 square plus 55 and minus 40 minus 55. 40 minus 55 means what? 15 square. Now 400 plus 225, 625. 625 root is what? 25. See that? Now once you are getting this is 25, now power factor cos phi is equal to what? VR by V. VR value how much? 20 by 20, 25. Getting 20 by 25, 4 by 5, 0.8. Lagging or leading, which is more? VR more or VC? VL more or VC more? VC is more. VC is more, that's why we should go for what? Leading. Na? That's why I can take it here 0.8 power factor according to this. As per this, we can get it. According to this, I will take it. This one 0.8 leading power factor. 0.8 leading power factor. Because VC is greater than VL. VC is greater than VL. That's why which is the correct option? D is the correct option. Na? Very good here. Is it okay? ఈ కరెంట్ అనేది మనకు అవసరం లేదండి. He was given that supply current for power factor no need because we are having the formula with that. Now let me consider the next one. Good one. An half-hour frequencies, the current RLC series circuit is equal to half-hour frequencies and cut-off frequencies. Cut-off frequencies and you should remember that the bell curve. Once you take that current and frequency, then definitely according to that, I will take it the current versus, this is the bell curve, under bell curve where we are getting that. This is F0, where F0 is equal to I maximum, where we are getting that I maximum by root 2 or IRMS. This is also called IRMS. At that we are getting F1 and F2. IRMS is what? 1 by root times of maximum current or current at resonance. Which is the correct option? Tell me that. Again, D. Option D. 1 by 2 times of current at resonance here. Current at resonance is maximum. Current at resonance is maximum. Is it okay? Very good. Now let me consider that under this one we should go for that magnetic circuits also. Sometimes two coils connected in series have an equivalent inductance of 0.4 when they are connected aiding and 0.2 when they are connecting opposing. Calculate the mutual inductance. Very simple here. You can get it now. The solution, I can take it for aiding and for opposing. It is what? I can take it L1 plus L2 plus 2M is equal to how much? 0.4. And L1 plus L2 minus 2M is equal to 0.2. What we will do that? Definitely we will make the subtraction. Once you subtract these two, then 4M is equal to 0.2, M is equal to what we are getting that? 0.2. Once you are subtracting that by 4, your M value how much you are getting that? 0.05. Yes or no? These are the simple calculations here. Option 1 is the correct one. Very good, very good. Yeah. All are giving correct answer. Very good. Next, see this. An AC current of RMS value 10 amperes is flowing in the circuit with a power factor of 0.5 lagging. If the supply voltage RMS is equal to, ikkada RMS ichchadu, ikkada RMS ichchadandi. Current RMS, voltage RMS ichchadu. The following equations are instantaneous equations. 0.5 lagging power factor. This is very important. Whenever 0.5 lagging power factor means cos phi is equal to 0.5. Then phi value how much? 60 degrees na? Lagging power factor. Lagging power factor means, suppose if you are considering that voltage is, what do you want that? First instantaneous current and voltages antandi. Current voltage is reference తీసుకున్నాం అనుకోండి. Current is lagging. Lagging means what? Negative. The first one is correct one because this is RMS current. This is what? Maximum, na? I maximum is equal to IRMS into root 2 because IRMS is equal to I maximum by root 2. Now this is in cosine, this is in cosine. That is also very important here. Examination lo same trigonometric function should be exist. Voltage cosine lo తీసుకున్నాం అనుకోండి, current also cosine you should express. Suppose if you take voltage as a sine, this is also sine. Now both are cosine, no doubt in that. 60. This is correct, this is correct. That's why first one is correct. Let me check it the next one. Here this is sine but this is cosine, but this is not correct. While coming to this is sine and this is sine, both are sine. But here it is leading. Current plus is there, that's why it is not correct. And here 10 sine omega t, 10. Here both are sine, but here this is what value? IRMS value. But what value we should consider? I maximum. While taking the instantaneous values, we should consider that I maximum. That's why option A is the correct one. Very good here. Next one. See that the R, L and C components having resistance or reactance of 40, J10 minus J10 respectively are connected in parallel with 3 branches, each with one element. This combination supply of 200 volts, 58 AC supply, the reactive power and apparent power, Guys, he was taken that resistor, inductance and capacitance. You can do it here, this. Each one element is given. This is 40 ohms and this is J10 and this is minus J10 given. Totally applied across 200 volts, 50 hertz. It's very simple here. Once you see that, what he wants? Reactive power and apparent power. Reactive power and apparent power means what here? We need to be consider reactive power. Q is equal to VI sin phi. Apparent power S is equal to VI. First of all, phi. Phi is what? Once you observe that, real part, imaginary part for this one, whatever the imaginary part, XL and XC, magnitudes are same. Here XL is equal to XC, which I can take it, BL value is equal to BC. Then what is the phase angle is equal to 0 degrees. Once phase angle is equal to 0 degrees, what I can take it? I can consider that here V psi phi Q sin 0 is what? Sin 0 is 0 VAR volt ampere reactive. But this is existing that. What is this is existing? Definitely I can take it this one. Here this 0, which option is there? 2 options are there. Here A is 0, both are 0 is there, D 0 and 1000 is there. Is it active power is existing? Yes, active power existing. How can you say that active power is existing? Active power I can easily identify here. V square by R, that is the active power, which is same as apparent power. There is no reactive power. My network is not having any reactive power means, which is existing only active power, which is nothing but the apparent power. That's why the P value is equal to directly V square by R. You need not consider VI cos phi here. Both are same. V square by R or I square into R also. Which one is comfortable? That you have to take it. Because these are the standard circuits. If is standard circuits kabatti, then we can take it V square. Nothing but what? 200 whole square by 40. Which one we are getting that? 1000 volt amperes. Watts actually. 1000 watts you are getting. This same as S is equal to under root magnitude P square plus Q square kada 1000 VA volt amperes vastadi. Then which is the correct option? Option D is the correct one. First identification emo reactive power 0. Second identification of active power is same as apparent power. This is the calculation part. Okay. Now let me consider the next one. Very good. Source is supplying only active power. Very good. Now see this. Given the following 3 currents are flowing in the 3 different branches in an AC circuit, IA, IB, IC. Guys, always you need to remember while you are doing the or while you are taking any AC circuit analysis example. Remember, గుర్తుపెట్టుకోండి. యూ షుడ్ రిమెంబర్ ఆల్వేస్. ఏసీ సర్క్యూట్ అనాలిసిస్లో ఏ క్వశ్చన్ సొల్యూషన్ చేస్తున్నా కూడా ఫస్ట్ ఈక్వేషన్ ఫార్మాట్లో ఇచ్చినప్పుడు ఆల్ ద వోల్టేజెస్ అండ్ కరెంట్స్ ఆర్ గివెన్ సేమ్ ట్రిగ్నామెట్రిక్ ఫంక్షన్ ఆర్ నాట్ వైల్ కంపేరింగ్ దట్. If same trigonometric function is not given, first you convert in terms of the same trigonometric function. ఆ సేమ్ ట్రిగ్నామెట్రిక్ ఫంక్షన్లో కన్వర్ట్ చేసుకున్న తర్వాత దెన్ యూ కెన్ కంపేర్. ఫస్ట్ లెట్ us take that here same trigonometric function, this is sine, but this is sine, but this is cosine. That's why you can write this in terms of sine. What is the formula for that one? Sin theta is equal to cos theta is equal to in terms of sine. Sin 90 plus theta, sin 90 plus omega t, or otherwise omega t plus 90. Are you getting? Now you take it a phasor diagram. Using the phasor diagram, I can take it here. See this one? Using the phasor diagram, I can take it. Tell me this. One by one, I can take it. First one is what? Minus 30 degrees IA. Minus 30 degrees IA. IA is equal to minus 30 degrees. This represent clockwise lo negative angle and IB is equal to what? This is also sine. That's why plus 90. This is IB. This is IB plus 90. Magnitudes are no need because phase angles are required here. According to the question, phase angles are required. And IC is equal to what? Plus 15 degrees. IC is equal to plus 15 degrees. See this one? ఇది IC plus 15 degrees. Now once you take that here, right, this is IC plus 15 degrees. Now you can compare here. ఈ లెంత్లు అనేవి బేస్డ్ ఆన్ దట్ వాల్యూస్. ఈ ఐసీ అనేది కొంచెం చిన్నది ఉంటుంది యాక్చువల్లీ అకార్డింగ్ టు దిస్ 7.77. యూ నీడ్ నాట్ బాదర్ అబౌట్ దట్. అవర్ కాన్సన్ట్రేషన్ ఈజ్ ఓన్లీ ఆన్ phasors. Now IB, IC, see this one. IA lags IB by an angle 30 degrees. IA lags IB by an angle not 30 here, it is 120 degrees. Now this is not correct. IB lags IC by an angle 15 degrees. IB lags IC by an angle 50 degrees, not. IC lags IB by 45 degrees, it is not 60 degrees, it is 45 degrees. It is also not correct. Now IC lags IA by 45 degrees, right? IC lags IA by an angle, IC leads here, that's why this is also not correct. Now IC lags IB by an angle 75 degrees. IC lags IB by an angle 75. 75 is correct here, not. This is not 45. 90 minus 15 is 75. IC lags. This one is correct here. IC lags. Because it is what? 90 minus 15, which is 75. Are you getting this? This is very simple. First main important thing is what? You should take that same trigonometric functions. Is it clear? Okay. Let's see this theorems, circuit theorems. Let me consider the circuit theorems. The Thevenin's equivalent voltage, V Thevenin's, in the following circuits. V Thevenin's in the following circuits. Okay, tell me that answer. The Thevenin's equivalent, tell me that. Thevenin's equivalent means what? Open circuit voltage andi. Open circuit voltage ante open circuit. First ee condition apply cheyalandi. Remember that. Thevenin's equivalent means, remember that. First apply this condition. That is very important. And identify the effect of that one. Effect ante 8 ohms neglect chesukovachu. Now with this we can take that VOC. This is nothing but what? V Thevenin's. ఇక్కడ కరెంట్ జీరో అవుతుంటే సేమ్ కరెంట్ ఇట్లా వెళ్ళిపోతుంది కదా. దెన్ కెన్ ఐ డిఫైన్ దట్ దిస్ వోల్టేజ్ యాజ్ విఓసి and this voltage is equal to 10 volts. Now can you apply that KCL? ఒకే ఒక స్టెప్ అండి, with one step you are going to get it here by KCL at VOC, by KCL at VOC, VOC minus 10 by 3, this is outgoing అండి, ఇక్కడ 0, this is incoming, ఇది ideal current source, this is incoming, that's why 12. Now VOC is equal to what I can take it, 36 plus 10, 46 volts. Very simple, only one step. B is the correct one. Are you getting? Brief explanation of theorems, sir. Theorems I will provide that PDF file, you will get it. Norton's equivalent. Norton's equivalent current and short circuit path current అండి. షార్ట్ సర్క్యూట్ పాత్ కరెంట్ అంటే పీడిఎఫ్ ఫైల్స్లో యూ కెన్ సీ దట్. దీన్ని అక్రాస్ షార్ట్ సర్క్యూట్ పాసివ్ ఎలిమెంట్ కెన్ బి నెగ్లెక్టెడ్. డైరెక్ట్గా వచ్చేస్తుందండి 50/3, how much, 16.7 amperes na? Yes sir, no? Is it okay? Is it right? 50/3 Norton's equivalent current. Is it clear? Any doubt? Very good. Next question. See this. Determine the Thevenin's equivalent voltage across the terminals A and B. Flowing circuit, consider 10 ohms resistor as a load resistor here. 10 ohms resistor load resistor ante first ee load ni తీసేసేయాలి. That is very important here. Including load తీసుకోకూడదు. లోడ్ రెసిస్టర్ తీసుకున్నామంటే అక్రాస్ లోడ్ వీఆర్ ఏబుల్ టు డిఫైన్ దట్ ఎంటైర్ నెట్వర్క్ యాజ్ ఏ థెవెనిన్స్ ఈక్వలెంట్. ఎంటైర్ నెట్వర్క్ యాజ్ ఏ థెవెనిన్స్ ఈక్వలెంట్. దట్స్ వై ఫస్ట్ మనం ఏం చేస్తాము, 10 ohmsని నెగ్లెక్ట్ చేస్తాం. దట్ మీన్స్ యూ డిస్కనెక్ట్ దట్ లోడ్ రెసిస్టర్. వన్స్ యూ డిస్కనెక్ట్ ద లోడ్ రెసిస్టర్, ఇఫ్ యూ వాంట్ టు ఫైండ్ అవుట్ దట్ థెవెనిన్స్ ఈక్వలెంట్ వోల్టేజ్, దిస్ ఈస్ ద, అండ్ once you imagine this, you can also get it here. Condition is same, whatever the condition we have considered in the previous, see this one 15, condition is same andi. What is the condition? Open circuit. Open circuit means what? We should consider that under open circuit definitely we have to take that current is 0. Ikkada current is 0. Then VOC. What you identify? Current 0 means no current in this one, no current in this one. That means how all are connected? These all are connected in series. These all are connected in series. అంటే 10 volts అనేది 2 plus 3 plus 5 అన్ని సిరీస్లో కనెక్ట్ అయి ఉంటే 10 volts across 10 ohms. Each 1 ohm how much? 1 volt. 5 ohms ఎంత? 5 volts. Then this value how much? This value you are getting that 5 volts. Okay. What about the polarities? Polarities ఎట్లా తీసుకోవాలండి? Polarities కరెంట్ డైరెక్షన్ బట్టి తీసుకోవాలి. ఈ కరెంటు ఈ కరెంట్ 0, then these 3 are connected, all are connected in series. Current is always in the source from negative to positive. That's why this is positive to negative. Now you can take it KVL to estimate that VOC. Are you getting? By KVL for VOC, by KVL for VOC. Tell me that this is positive to negative. Starting if you take that minus, plus, plus, minus. అంటే నెగిటివ్ అని ఒక సైడ్ తీసుకున్నాం అనుకోండి, VOC ప్లస్ 15 ఈజ్ ఈక్వల్ టు వాట్ ఐ కెన్ టేక్ ఇట్ 20 ప్లస్, ఎస్ ఆర్ నో, రైట్, 20 ప్లస్ వాట్ ఐ కెన్ టేక్ ఇట్ హియర్ కరెంట్ డైరెక్షన్ అకార్డింగ్ టు దిస్ వన్, రైట్, 20 ప్లస్ 5. నౌ వాట్ ఐ కెన్ టేక్ ఇట్, VOC ఈజ్ ఈక్వల్ టు 25 minus 15. VOC ఈజ్ ఈక్వల్ టు, ఇస్ ఇట్ రైట్? VOC is equal to 10 volts. Yes or no? Plus 10 or minus 10? This is plus 10 only. Then which is the correct option? C is the correct option. Are you getting? Sometimes you may think that here this totally 20 will be cancelled, 0 you may take it. But it is not 0. It is what? C is the correct option. Are you getting? Are you getting the clarity? Very good here. Very good. Next question. See this one. Determine the maximum power transferred in the source to the load. Maximum power in watts తీసుకోవాలండి. How you are getting that? Maximum power in watts. If you want to get it that, first maximum power transfer theorem apply చేయాలంటే లోడ్ని వేరియబుల్ కాదా. నెక్స్ట్ ఏం చేయాలి? These two are connected across the load circuit, entire network. Across load circuit, entire network is Thevenin's equivalent. అంటే here we should be convert this total network across this as a Thevenin's equivalent. దానికి నేను ఏం చేస్తానంటే I would like to use that, what I want to take it that I would like to use the here source transformation. ఈ 20/8 ఉంది కదా, parallel 8 ohms resistor వస్తుంది. 20/8 nothing but 10/4 2.5 amperes is upward direction. ఇక్కడ 10 amperes is upward direction. 8 and 1 are connected in parallel. Now from this I can take it 8 and 1 are connected in parallel. Finally I will consider that across load Thevenin's లో చేయండి అండి. How much you are getting that? Across load first current source తీసుకుంటే 8 into 1/8 plus 1 9 and 20/2.5 and 12.5 amperes. This one we should convert in terms of again source transformation I into R. Now 12.5 into 8. 12.5 into 8 how much? Here we are getting that 100 by 9 volts. Same resistor here. Now what I can take it 8 by 9 ohms. You can take it here directly. P maximum is equal to V square by 4RL. V square by 4RL. Now V square value how much? 100 by 9. DC కాబట్టి ఈ ఫార్ములా యూజ్ చేయొచ్చండి. AC అయితే మీకు ప్రాబ్లం ఏమో కానీ DC you can apply this formula directly. DC you can apply this formula directly. See this one. This one you are getting a 1919 will be cancelled. What we are getting, this is 25 and this is 12.5. What we are getting that 25 12.5 by 2. You can take it 25 by 2 na? Yes or no? 625 by 9. 625 by 9 I can take it. 9 means 18. How much you are getting this one? Tell me this. 625 by 18. 625 by suppose nearly equal to 20, suppose if you are considering that. Here 30 point something or 31 or 35 you can get it. Option D is the correct one. Option D is the correct one. Are you getting? Is it right? Near answer you can take it. Nearer answer you can take it. Is it okay? Right. 30.86 is 20, okay, less than that na. If you take it here 625 by 18 more than 20, if you 20 తీసుకుంటేనే నీకు 30 point something లో వస్తుందండి, 35 వస్తుంది. Is it right? Very good, very good. Now see this one. Using the superposition theorem, tell me this one. Using the superposition theorem, tell me this. Determine the current denoted IA. Determine the current denoted IA. Superposition తీసుకోవాలని రూల్ ఏం లేదండి. ఎగ్జామినేషన్లో దీస్ టైప్ ఆఫ్ క్వశ్చన్స్ రిమెంబర్ దట్. ఆ క్వశ్చన్ సూపర్పోజిషన్ తీసుకోమని అడిగాడే కానీ ఇఫ్ యూ వాంట్ టు యూజ్ దట్ యూ కెన్ యూజ్ ఇట్, ఆర్ అదర్వైజ్ వన్ స్టెప్లో వచ్చేస్తుంది. సూపర్పోజిషన్ థియరం తీసుకుంటే డైరెక్ట్గా వితౌట్ టేకింగ్ క్యాలిక్యులేషన్, వితౌట్ పుటింగ్ పెన్ యూ కెన్ ఆన్సర్. సూపర్పోజిషన్ తీసుకుంటే ఏంటి, ఇది ఓపెన్ సర్క్యూట్, దెన్ టోటల్ హౌ మచ్ యూ ఆర్ గెటింగ్ దట్ 6/12 1/2 amperes. Now while taking this one is short circuit, then current is dividing into in two ways, nothing but what, 2 amperes you are getting, 2 into 1/2, nothing but what, 2 into 1/2, 2.5. Option D is the correct one. Like that we can take it. Yes or no? Are you getting? ఇది ఓపెన్ సర్క్యూట్ అయితే దిస్ యూ కెన్ నెగ్లెక్ట్. దెన్ అండర్ ద టైమ్ 6/12 1/2 0.5, ఇది 2 equal 2.5. It's very simple. Right, this one. What is the value of resistor R for maximum power dissipated in 3 ohms resistor? ఇది 3 ohms అనేది లోడ్ అంటున్నాడండి. లోడ్ ఫిక్స్డ్ ఆర్ వేరియబుల్? ఫిక్స్డ్. వన్స్ లోడ్ ఈజ్ ఫిక్స్డ్, వీ నీడ్ టు సీ దట్ minimum internal impedance, if it is fixed, remember that, guys, remember, MPTT, maximum power transfer theorem, is not valid. If maximum power transfer theorem is not valid, then definitely we should go for what? We need to be consider maximum power transfer theorem is not valid, RS will be minimum. So, ikkada options ichinapudu, which is minimum, that value you have to take it. Suppose 0 undanuko, that is minimum, that you can select. Other than the 0 is given, we should compare that, which is minimum. 3 ohms is the minimum. Fourth option is the correct one. This R value అనేది, this is not load. It is not load. It is not load. It is the source side only. That's why minimum internal impedance we should be select for maximum power transfer in the fixed load resistor. Fixed load resistor. Yes. Yes or no? Right. Transients. ఈ ట్రాన్సియెంట్స్లో చూడండి, సోర్స్ ఫ్రీ సర్క్యూట్స్, ఈ సోర్స్ ఫ్రీ సర్క్యూట్స్లో ఉన్నాయి. దిస్ వన్ ఈజ్, సి దిస్ వన్, ఇవి గుర్తుపెట్టుకోవాలి. దిస్ ఈజ్ వెరీ ఇంపార్టెంట్ అండర్ ట్రాన్సియెంట్స్. at t equal to 0 ప్లస్ t equal to infinity, t greater than 0 ఎట్లా యాక్ట్ చేస్తున్నాయి. ఈ టేబుల్ ఒకటి చాలా ఇంపార్టెంట్ అండి. ఇది లాప్లాస్కి ఈ టేబుల్ కూడా ఇంపార్టెంట్. దిస్ టేబుల్, బోత్ ద టేబుల్స్ ఆర్ very much important for transient circuit analysis. Now see this one. Question is, two coils having equal resistance but different inductances are connected in series. The time constant of the series combination is, time constant of the series combination, tell me this, time constant of the series combination. Two coils and resistance, coil is nothing but combination of resistance and inductance, you can take it. One more coil, resistance and inductance, which are having but different inductances, equal resistances, R. This is L1 and L2. I can take it here. Suppose if you are considering this one, this total, this is the coil 1 and this is the coil 2. Time constant adugutunnadandi. Individual time constant enti T1, tau 1, tau 2. Now total time constant tau is what? This is L1 by R, this is L2 by R. Total time constant emuntadi here? L1 plus L2 by R plus R, nothing but what? 2R na? I can take it, this one is 2R. Under that instant I can take it here, this one is, can I write that L1 by R plus L2 by R by 2, nothing but tau is what? Tau 1 plus tau 2 by 2, average na? Are you getting this? The average of the individual time constants, this was the previous examination question. The average of the individual time constant, average of the time constant of individual coil, right? This one is the correct one. This one is the correct one. Is it right? Are you getting? Is it okay? Are you following this? Very simple. Simple questions here. All right, see this one. The transient response of initially relaxed RC circuit. RC circuit directly na? RC circuit current equation andi. Voltage equation అయితే 1 మైనస్లో ఉంటుంది. దీనికి 2 ఫార్ములాస్ ఉన్నాయండి. Those formulas for current of inductor, by knowing the initial value, final value. By knowing the initial value and final value. Initial value, final value. Inductor kaite IL of t is equal to IL of infinity plus IL of 0 minus IL of infinity into e to the power minus t by tau. Capacitor kanuko voltage, energies kada. VC of infinity plus VC of 0 minus VC of infinity into e to the power minus t by tau. Is it right? Now current అనేది, voltage అనేది 1 మైనస్లోకి వస్తుందండి. There is no initial value. ఇనిషియల్ వాల్యూ లేదంటున్నాడు కాబట్టి కెపాసిటర్ ఇనిషియల్ వాల్యూ ఈజ్ ఈక్వల్ టు 0, ఇది తీసుకుందాం. అండ్ ఫైనల్ వాల్యూ ఎప్పుడు వస్తుంది? అట్ t ఈక్వల్ టు ఇన్ఫినిటీ. అట్ t ఈక్వల్ టు ఇన్ఫినిటీ, ఇఫ్ యూ టేక్ ఇట్ హియర్, దిస్ స్విచ్ పొజిషన్ ఈజ్ క్లోజ్డ్, కెపాసిటర్ యాజ్ ఓపెన్ సర్క్యూట్. ఇఫ్ యూ డూ దట్, హౌ మచ్ వాల్యూ ఆర్ గెటింగ్ దట్? V na? This is the final value is equal to V minus V into e to the power minus t by tau, where tau is equal to RC. Now V times of 1 minus e power minus t by tau. This is what? Voltage. But what he wants? Current. Na? If you want to get the current, using the voltage, can you define the current? Right. I can define that current. IC is equal to same current is passing through that, which is same as IC of t is equal to C into dVC of t by dt. Direct వచ్చేస్తుందండి. C into differentiation, this value is equal to 0 and e power minus t by RC into minus 1 by RC. అంతే కదా differentiation. E power 80 differentiation, e power 80 into a. ఇక్కడ CC will be cancel. Finally V by R into e to the power minus t by RC. This is the current expression here. This is the current expression. You can easily remember that. You can easily remember. Voltage అనేది exponential rising function, but current అనేది decaying function. Current అనేది decaying function అండి. Because at t equal to infinity, current value how much? 0. Capacitor act as what? Open circuit. That's why if you see that the graph here, by using the graph here, this is the voltage expression of this one. This is VC. But while coming to that here, what about that IC? IC expression or current expression will be like this, decaying expression. This is I of t value. Because at t equal to infinity, voltage is maximum but current is 0. Voltage is maximum but current is 0. Whenever capacitor is charging, capacitor is charging. One simple example you can take it. Suppose if you go to hotel, you order one meal. Starting your stomach is empty, nothing but starting capacitor is not charged, empty. Food on the plate is maximum, total food ఉంటుంది అక్కడ. ఆ ఫుడ్ అనేది కరెంట్ తీసుకుందాం. వన్స్ యు ఆర్ కన్సిడరింగ్ దట్ ఫస్ట్ స్టార్టింగ్ ఫుడ్ ఎంత ఉంది, maximum ఉందండి. వోల్టేజ్ ఎంత ఉంది, నథింగ్ బట్ వాట్ యువర్ స్టమక్ ఈజ్ నిల్. వన్స్ యు ఆర్ టేకింగ్ ద ఫుడ్, యువర్ స్టమక్ ఈజ్ ఇంక్రీజింగ్, నథింగ్ బట్ చార్జ్ అక్రాస్ ద కెపాసిటర్ ఈజ్ ఇంక్రీజింగ్, వోల్టేజ్ ఈజ్ ఇంక్రీజింగ్, బట్ current is decreasing, food in the plate is decreasing. Then once here if you reach the steady state, nothing but once your stomach is full, food on the plate is nil. That's why decaying function current ఉంటుంది, right? You can easily remember like that. Okay, next one you can take it. Here two port network parameters. ఈ ఫార్ములాస్ని మనం టూ పోర్ట్ నెట్వర్క్ పారామీటర్లో గుర్తుపెట్టుకోవాలండి. You should remember all these, should remember all the formulas. ఈ ఫార్ములాస్ తోటి కండిషన్ ఫర్ సిమెట్రీ, కండిషన్ ఫర్ రెసిప్రోసిటీ తోటి గుర్తుపెట్టుకోవాలి. నౌ లెట్ మీ కన్సిడర్ దట్ సమ్ ఎగ్జాంపుల్స్ ఆన్ దట్. ఆర్ యు గెటింగ్? ఇస్ ఇట్ ఓకే? రైట్, క్వశ్చన్ చూద్దాం. ఇది లాస్ట్ ఎగ్జాంపుల్ ఇచ్చాడండి. ఏ టూ పోర్ట్ నెట్వర్క్ ఈజ్ డిఫైన్డ్ ఫర్ ద ఫాలోయింగ్ పేర్ ఆఫ్ ఈక్వేషన్స్. I1 is equal to V1 plus V2, I2 is equal to V1 plus V2. ఇట్స్ ఇంపిడెన్స్ పారామీటర్స్. ఇక్కడ కరెంట్ ఈక్వేషన్స్ ఇచ్చాడండి. ఈ కరెంట్ ఈక్వేషన్స్ ఇచ్చినప్పుడు వాట్ వీ కెన్ ఎక్స్ట్రాక్ట్ దట్ కరెంట్ ఈక్వేషన్స్ నుంచి వై పారామీటర్స్ ఎక్స్ట్రాక్ట్ చేస్తాం. వై పారామీటర్స్ వచ్చిన తర్వాత ఇన్వర్స్ ఆఫ్ దిస్ వన్ ఈజ్ జెడ్ పారామీటర్స్. హియర్ కరెంట్ ఈక్వేషన్స్ ఇవి కదా, వై పారామీటర్స్. నౌ యూజింగ్ దట్ ఐ కెన్ డిఫైన్ ఫస్ట్ అండర్ ద సొల్యూషన్ we will consider that I1 is equal to 2V1 plus V2, I2 is equal to V1 plus V2. అంటే y పారామీటర్స్ మ్యాట్రిక్స్ వచ్చేస్తుందండి 2 1 1 1. Z is what? Y inverse. Directly assist here 1 by AD minus BC, D minus B minus C A. With that we are getting 2 minus 1 minus 1 1. Where it is? 2 minus 1 minus 1 minus 1. That is what D is the correct option. Are you getting? ఇచ్చిన ఈక్వేషన్స్ అనేవి ఏమి ఈక్వేషన్స్? వై పారామీటర్స్ ఈక్వేషన్స్. ఫస్ట్ గెట్ ద వై పారామీటర్స్, దెన్ టేక్ ద ఇన్వర్స్, యూ విల్ గెట్ ద జెడ్ పారామీటర్స్ మ్యాట్రిక్స్. ఇస్ ఇట్ రైట్? ఓకే, ఎనీ డౌట్? ఓకే, రైట్. When a number of two-port networks are connected in cascade, the individual what? Chain matrices are multiplied. Nothing but cascade means what? ABCD parameters here. ABCD parameters can be multiplied. ABCD parameters can be multiplied. It is very simple. Now, din cheppandi, which is the correct option? Tell me from your end. I made 23. Last 10 minutes we are having. For the two-port network to be reciprocal means what? Reciprocal means AD minus BC is equal to 1. AD, this is not correct. This is symmetric. This is reciprocal. This is symmetric. This is not correct. This is reciprocal and this is reciprocal. Now this one is correct. Let me consider this one. Here negative should be there. That's why this is not correct. C is the correct one. Yes or no? Simple questions. And two two-port network transmission parameters are given. Multiplication. Multiplication, you have to take it that. Option B is the correct one. Total cascaded and multiplication ichchadandi B. Is it right? Are you getting? C must be. Where C must be the answer? All right. చూడండి. H parameters H11 and H22 are related with Z parameters. ఇది కొంచెం H11ని Z parametersలో and Y parametersలో, H11ని Z parametersలో, H22ని Y parametersలో రాయాలి. అంటే దానికి డిఫైన్ చేయాలండి. H11 is equal to what? It is V1 by I1 when V2 is equal to 0 actually. Right? Because H parameters లో అంటే ఏంటి? V1 is equal to H11 I1 plus H12 V2. V2 0 చేయాలన్నమాట. V2 0 చేయాలి. Then what about the next one? H22. H22 అంటే ఏంటి? Here I2 by V2 when I2 by V2 when V1 is equal to, when I1 is equal to 0. ఇదేమో షార్ట్ సర్క్యూట్, ఇదేమో ఓపెన్ సర్క్యూట్ అనమాట. Now how you take it that according to that H11 is equal to, you can get it here short circuit. Short circuit parameters అంటే ఏంటి? Y parameters. Open circuit parameters అంటే Z parameters. That's why you can take it H11 is equal to, ఇది impedance కదా, inverse of this one. If you take inverse, then definitely 1 by Y11. This is what? Admittance. But open circuit కాబట్టి impedance 1 by Z22. Like that you can take it. Very simple. ఇది ఇంపార్టెంట్ అండి. కండిషన్ ఈజ్ వెరీ ఇంపార్టెంట్. షార్ట్ సర్క్యూట్ కాబట్టి షార్ట్ సర్క్యూట్ పారామీటర్స్. ఓపెన్ సర్క్యూట్ మీన్స్ ఓపెన్ సర్క్యూట్ పారామీటర్స్, జెడ్ పారామీటర్స్. Now which is the correct one? Option C is the correct one. Is it right? Very good. Remaining subjects kuda classes conduct chestaru. Yes. Day after tomorrow you are having. One day we are giving gap. That timetable also I will provide you. ఇది షంట్ ఎలిమెంట్ అంటే షంట్ ఎలిమెంట్కి జెడ్ పారామీటర్స్ని, సిరీస్ ఎలిమెంట్కి జెడ్ పారామీటర్స్ కెనాట్ బి డిఫైన్డ్. దీనికి ఇంపెడెన్స్ పారామీటర్స్ మ్యాట్రిక్స్ ఆర్ఆర్ఆర్ యూ విల్ గెట్ ఇట్. అండ్ ఇంపెడెన్స్ మ్యాట్రిసెస్ ఆఫ్ టూ నెట్వర్క్స్, ఇఫ్ దీస్ నెట్వర్క్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్, టోటల్ నెట్వర్క్ సమ్ అండి, సమ్ యూ టేక్ ఇట్ 3 + 15, 2 + 5, 2 + 5, నౌ 3 + 25. నౌ విచ్ ఈస్ ద కరెక్ట్ ఆప్షన్? బి ఈస్ ద కరెక్ట్ ఆప్షన్. సిరీస్లో ఇవి కనెక్ట్ చేయొచ్చు. కన్సిడర్ ద స్టేట్మెంట్ అస్ 2 పోర్ట్ నెట్వర్క్స్ ఆర్. ఇది రెసిప్రోకల్, ఇది రెసిప్రోకల్. దిస్ ఈజ్ నాట్ కరెక్ట్. దిస్ ఈజ్ ఆల్సో రెసిప్రోకల్. దట్స్ వై 1, 2, 4 ఆర్ కరెక్ట్. ఆర్ యు గెటింగ్? 1, 2, 4 ఆర్ కరెక్ట్. ఎస్ ఆర్ నో? ఇస్ ఇట్ రైట్? Now with respect to transmitted parameters, which one of the A and B are the dimensionless? A and ఏంటి? V1 by V2. A and D are the dimensionless. C is the correct one. Equations, once you write that, definitely you will get it. You need not worry about this. And if the connection of the two-port networks, such as transmission overall network, product of the transmission network, individual network, what type of connection? Cascade connection. Right. If two network hybrid parameters ఏంటి? V1, I2 and V2 and I1. Option D. Yes or no? Right. ఇదే సేమ్ ఇంతకుముందు చూసాం కదండి. Z12 వాల్యూ ఇక్కడ మనకి I1 2V1 V2, I2 2V1 3V2. అంటే Y పారామీటర్స్ మ్యాట్రిక్స్ ఇచ్చాడండి. Y పారామీటర్స్ మ్యాట్రిక్స్ ఇస్తే 2, 1, 2, 3 ఇచ్చేసాడు. మనకి యాక్చువల్గా Z12 కావాలి. Z12 అంటే ఏంటి? ఇక్కడి నుంచి Z12 డైరెక్ట్గా తీసుకోవచ్చండి. ఇంపెడెన్స్ కదా. ఇంపెడెన్స్ ఈజ్ నథింగ్ బట్ వాట్ ఈజ్ ద రేషియో ఆఫ్ వోల్టేజ్ టు కరెంట్. వెన్ ఇంపెడెన్స్ పారామీటర్స్ ఆర్ వాట్ పారామీటర్స్? ఓపెన్ సర్క్యూట్ పారామీటర్స్నా I1 is equal to 0 చేసేసి దెన్ వీ నీడ్ టు గో ఫర్ దిస్ వన్. ఆర్ అదర్వైజ్ జెడ్ పారామీటర్స్ని 1/AD మైనస్ బీసీ టోటల్ కావాలంటే ఇట్లా చేయొచ్చండి. 1/AD మైనస్ బీసీ 6 - 2 4 D minus B minus C A, nothing but what? Z12 value minus 1/4, option D. Z12 is equal to minus 1/4. ఇక్కడ కూడా సేమ్ అదే వస్తుంది. when I1 is equal to 0, V2 is equal to minus 2V1. ఇక్కడ V2 వాల్యూ minus 2V1 చేసామనుకోండి, minus 6V1, 2 minus 6 minus 4V1. I2 is equal to minus 4V1. V1 by I2 is equal to 1/4 minus 1/4. Directly we are getting, both are same. Yes or no? ఈ గ్రాఫ్ థియరీకి వచ్చేసరికి ద ఫార్ములా ఫైండింగ్ ఇది ఒక్కడే ఇస్తున్నాడండి ఆల్వేస్. సమ్టైమ్స్ ఈజ్ ప్రొవైడింగ్ దట్ number of links L is equal to B minus N plus 1 actually. L is equal to B minus of N minus 1. ఇక్కడ number of twigs, number of here links, number of twigs N minus 1 and some basic definitions are there. Those basic definitions for tree, cut set, tie set ఇవన్నీ తెలుసుకోవాలి మీరు, రైట్. బట్ సమ్టైమ్స్ ఇట్లాంటివే ఇస్తున్నాడు, మ్యాక్సిమం ఇట్లాంటివి వస్తుంది. N minus 1 number of nodal equations equal to N minus 1 ట్విక్స్ అనమాట. ఇవి లింక్స్, ఇవి ట్విక్స్. ఒక ట్రీలో లింక్స్ ప్లస్ ట్విక్స్ ఈక్వల్ టు టోటల్ బ్రాంచెస్, లింక్స్ ప్లస్ ట్విక్స్ ఈక్వల్ టు టోటల్ బ్రాంచెస్. మ్యాక్సిమం ఇదే వస్తుందండి. బట్ యూ షుడ్ గో ఫర్ సమ్ నాలెడ్జ్ రిగార్డింగ్ ద గ్రాఫ్ థియరీ, రైట్. నౌ 3-phase circuits. A balanced 3-phase star connected voltage source has phase sequence ABC. If the voltage of phase A neutral to neutral is equal to 10 at an angle 0 degrees, the line voltage with respect to BC. ఇది here you know that this is very simple now. Phase voltage ఇచ్చాడండి, V phase VAN ఇచ్చేసాడు. VAN is given 10 at an angle 0 degrees ఇచ్చాడు. అండ్ VBC కావాలంటున్నాడండి, VBC కావాలంటున్నాడు. రిమెంబర్ దట్ హియర్ నార్మల్గా phase in 3-phase circuits, phase voltage, line voltages are different, and you know that phase voltage lags line voltage by an angle 30 degrees. These basic information you should have, right. Now మనకు తెలిసింది ఏంది, ఇవి లైన్ వోల్టేజెస్ అయితే అంటే VAB, VBC, VCA ఇవి అట్ అన్ యాంగిల్ 0 degrees. దిస్ ఈజ్ అట్ అన్ యాంగిల్ minus 120. ఎందుకంటే పాజిటివ్ ఫేజ్ సీక్వెన్స్ అన్నాడండి, దట్స్ వై ఐఎమ్ కన్సిడరింగ్ దిస్ వన్. అండ్ దట్ హియర్ వాట్ ఐ కెన్ టేక్ ఇట్, దీస్ ఆర్ VAN 30 degrees minus 30, VBN minus 30, VBN ఎంత minus 150 వస్తుంది ఇక్కడ. దిస్ ఈజ్ వాట్ ప్లస్ 90 వస్తుంది VCN. దీస్ ఆర్ వాట్ వోల్టేజెస్, ఫేజ్ వోల్టేజెస్. He wants to take that the phase voltage as a reference. See this one, 10 at an angle 0 చేసాడండి. అంటే VAN minus 30ని నేను కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్లో we should move at an angle 30 degrees. Then on that time VAN is going to be 0 degrees. Now let me consider that. Let us see that how we are getting దీన్ని VANని 0 degrees చేశాను అనుకోండి. అప్పుడు VAB ఏమవుతుంది, VAB is going to be plus 30 degrees. 0 30 degrees plus 30 degrees అవుతుంది. అంటే VBC కావాలన్నాడు. We need to VBC in clockwise direction we need to get it from plus 30 to what it is 120 degrees phase shift na, from here to here 120 degrees phase shift. ఇది కూడా 30 degrees అడిపోతుంది అనమాట, అంటే minus 90 ఇక్కడికి వస్తుంది అనమాట. VBC is equal to at an angle minus 90 degrees. VBC nothing but what, VL is equal to √3 times of V phase. అంటే ఇక్కడ 10 at an angle 0 degrees ఇచ్చాడంటే √3 times of 10√3 at an angle minus 90 or plus 90, minus 90. Which is the correct option? D is the correct option. Have you got this? This you have to know that the angle between phase or line voltages is equal to 120 degrees ఉండాలండి కంపల్సరీగా. అంటే ఇక్కడ ఇదేమవుతుంది విసిఏ, ఇది విఏఎన్ ఇస్ ద రెఫరెన్స్ తీసుకున్నాడు. అట్లాటప్పుడు దట్ వాల్యూ విల్ గెట్ విబిసి అట్ అన్ యాంగిల్ -90. ఇక్కడ హియర్ ఇన్ స్టార్ కనెక్షన్ యూ షుడ్ నో దట్ లైన్ వోల్టేజ్ ఫేజ్ వోల్టేజ్ డిస్ప్లేస్డ్ 30 degrees. దట్ వాల్యూ యూ హ్యావ్ టు నో దట్, రైట్? నౌ 2 watt meter readings for measuring 3-phase is employed in a 3-phase balanced system with current coils connected in A and C lines. The phase sequence is ABC. The current coil in phase A reads 0. Then the power factor of the load will be. Then definitely you can get it what? Tell me this. This is a good example. 2 watt meter method lo power employed in 3-phase balanced system with current coils A and C. A and C lo current coil chesadandi. Then what we are getting, the one of the wattmeter reading equal to 0. One of the wattmeter reading equal to 0. What angle you are getting that? Both are here. Suppose both are equal. Phase angle 0 andi. One of the wattmeter reading equal to 0. What we are getting that? Power factor value how much? Here phase angle అనేది పవర్ ఫ్యాక్టర్ అనేది ఫేజ్ యాంగిల్ అంటే tan ఇన్వర్స్ √3 times of W1 minus W2 by W1 plus W2. Sir, no? Tan phi value you are getting that. అంటే వన్ ఆఫ్ ద వాట్మీటర్ రీడింగ్ ఈక్వల్ టు 0 అంటే W2 రీడింగ్ 0 అనుకోండి, దాన్ని ఏమవుతుంది ఇయర్ tan phi ఈజ్ ఈక్వల్ టు √3. tan phi ఈజ్ ఈక్వల్ టు √3 అంటే ఏంటి? phi ఈజ్ ఈక్వల్ టు 60 degrees. Phi equal to 60 degrees means what? Here what we are getting that 0.5. 0.5. Is it leading power factor or lagging power factor? Definitely leading power factor, lagging power factor means what? The power factor is equal to cos phi value is equal to 0.5. 0.5, which is that what? Is it leading power factor or lagging power factor? According to that, the balanced system 2 watt meter method, the phase sequence ABC, coil A reads 0. The power factor of the load is 0.5. Lagging or leading? which one value you are getting that as 0? Then definitely when current is equal to 0, it is going to be that here 0.5 leading power factor. 0.5 leading power factor. Is it right? Is it clear? 0.5 lagging power factor. Right. According to this here, once you consider that lagging power factor, as per the lagging power factor you can take it. Coils, na? Current coils, according to that, it is a balanced load, no doubt in that. Lagging power factor, right? See this one. A 3-phase star connected supply of phase voltage 100 volts 50 hertz is supplying the 3-phase star connected resistive load of 5 ohms per phase. Find the total active power. This is very simple here. What it is given? 3-phase star connected supply phase voltage. Phase voltage is 100. Line voltage value how much? V phase is equal to 100 given. V line is equal to 100 √3 volts. And 3-phase star connected. Directly you can take it here. You need not go for this total stuff. Directly this is balanced na. P 3-phase is equal to 3 times of single phase. 3 times of V square by R. Very simple here. How much you are getting that? 10,000 by 5. Nothing but 2,000. 6,000 na. This is very simple. Yes or no? Is it clear? Okay, very good. Think without ink. Sir, why you are doing this question? Direct questions, no doubt. Right. This is about the Mahender. VB. No, no, no. Mahender, whatever you are considering VB minus VC, you need not consider that. But once you take any three-phase circuits, you should know that for star connected and delta connected, which are same, which are different. Under that, you should know that for star connected supply system, the phase voltage lags 30 degrees with respect to line voltage. While taking the delta connected load, phase current leads line current by an angle 30 degrees. But the phase displacement between that line voltage, line current for inductive load 30 plus 5. This VB minus VC, if you take that, you will get it, no doubt in that. Suppose if you take that VB minus VC, VB minus VC is what? B values, C values, again you need to go for that. But once you using the phasor diagram, you can easily get it. Right? Without pen means, why I am doing each and everything, you just remember that. If you are getting, you are already practiced. I am doing each and every step for those who are started now. Some of the students, they may not get it. For that, evarkaite simple way lo or those who are not understanding properly step by step, for them I am giving directly. I am taking that each and every step. Vallaki each and every step estene ardham avutundi. That's why I am taking this one. Okay? And here, this is the total, the schedule which we are having. Oh, this is not Polytechnic. Okay. These are the test series we are providing. Okay. Guys, today whatever the discussion we made, I hope this is somewhat helpful, but at a time if you go through that, the live session, you may get some confusion. Those who are having average students ki koncham confuse avutu untaru. But once okkasari live ayipoyin tarvata, tomorrow, because you are having tomorrow the gap, day after tomorrow you are having control system, right? And ee Polytechnic lecturers ki evaraithe prepare avutunnaro, ippudu ee roju session ki each and every topic lo nenu weightage kuda chuinchanu. According to that, you go through that each and every topic ni తీసుకోండి. రేపు ఒక్కసారి లైవ్ ని మళ్ళీ చూడండి. ఈచ్ అండ్ ఎవ్రీ క్వశ్చన్ ని హౌ we are solving that. You just get the concept with this one. Okay? Thank you and all the best for Polytechnic examination, lectures examination. మీరు according to the proper plan, schedule వేసుకోండి. According to the proper plan, each and every subject ni complete cheyandi first. Mock testlu or test series, online testlu aithe compulsoryga attempt cheyalandi. Those who are going to write the online tests or offline tests, definitely they will get confidence. Definitely they will get the confidence in the examination. ఒక సబ్జెక్ట్ అయిపోయిన తర్వాత కంపల్సరీగా అట్లీస్ట్ 1 or 2 టెస్ట్లు మీరు ప్రాక్టీస్ చేయాలి. దిస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్ for those who are going to write the examination for this Polytechnic lecturer examination. Okay? If you are having any doubts, you can post it in Telegram channel, then we are able to solve each and every example or each and every doubt. Okay? Thank you. I hope that today's class definitely it will be useful for you. Okay? Thank you. All the best.